In this video, you're going to learn how to make an AI computer vision model without any code at all using MLForge. So without further ado, let's get right into it. Before we get started, it's important that you have Python and pip already installed in your system. If you don't, you won't be able to download or install MLForge. However, you can go to the internet and actually download both of these things relatively easy. If you have both those downloaded, that's great. Let's go ahead and get into installing. So I'll go into our search bar, type in terminal, and it'll first download some dependencies. So first I'll do pip, install torch, and torch vision. These are the two machine learning libraries we need to actually, train our models. If you don't have this, you won't be able to actually train a model in MLForge. So I already have these downloaded, but if you don't, it'll take a while, so just be patient. Now we can actually install MLForge. So I'll do pip install zaina-ml-forge. Great, and then after that, I'll do ml-forge in our terminal to actually run the app. Alright, as you can see, it works perfectly, but before we even touch any, creating models or doing data, it's important that we get a good file structure going. Let's get right into that. Alright, let's get some file structure going. First, I'm going to go to my file explorer, and then I'll head into this machine learning folder, and I'll create a new folder that's going to house all of our MLForge projects. So I'll create a new folder called ml-forge-projects. Great. I'll go into that and I'll create our project folder for this specific project. So I'll create a new folder, I'll call it project 1. And in this folder, we're going to find our model, our .mlf file that's going to contain our actual project, and also our exported PyTorch code when we eventually save that. So now that we have that set up, we can go back to MLForge and press Ctrl S, and then I'm going to go to my OneDrive, desktop, machine learning, and then MLForge as projects, and then project 1. This is where we're going to save our project.mlf. As you can see, our console says that it was saved, and then we can actually get into creating our pipeline. So before we create our pipeline, let's actually get a good view of the app. So on the left here, we have all our blocks. This is everything that we need to actually create and train our model. To the right, we have our training configuration where we set the amount of epochs, and we also set our device, our checkpointing, early stopping, and we also get to see what our model actually looks like. If we scroll down, we see our loss and accuracy curves. And at the bottom, we have our console. Here, we'll see any errors, our training stats, and really stuff like that. And at the top, we have our menu where we can, open and save files. And we can actually load a template if we want to. We can, undo, redo, and then if we can create and close tabs and run over here, we can actually run inference. And we're actually going to do this after we train our model to see how our model actually is. And then here we get to see some documentation and what the app's about. And here is our sort of main thing where we can run, pause, or stop training. We also have metrics, which is where we get to see the graphs on this window. Alright, now they have a good idea of what the app looks like. Let's actually get right into it. So we have 3 tabs preloaded in for us. It's our data prep, our model, and our training. That's sort of the 3 parts of actually creating a machine learning pipeline. So first you need to prepare your data, create your model, and then train it, of course. So what we're creating today is a handwritten digit classifier using the MNIST dataset. So we'll create a model that it'll be given an image with a handwritten digit, and it'll be able to classify that. So an image of 5 will say, okay, this number is 5. So the first step here is downloading and setting up our data. Let's delete the starter node, and we'll go down to data prep, and I'll take in 2 MNIST nodes. And then you can see we have 3 parameters here: root, train, and download. Our root here says, okay, where are we downloading this? I'll put data for both of those. Train is asking, okay, true or false, are we getting the train data set or the test data set? So I'll make this one the train data set and make this one the test data set. So the train data set is essentially what we're giving to the model, and the model is going to learn off of that. But the test data set, the model is just testing how well it does. So this is sort of the benchmark. This is actually the learning tool. And then to download, it's asking, hey, do we want to download this data set? Of course we do. So yeah. And then after that, we're going to need something called transforms. Transforms essentially turns an image into numbers, because all machine learning models need numbers. So we'll go into our augmentation here, and we'll get 2 tensors. Tensor, we'll get 2 of those. And I'll drag this and connect both. And essentially this is turning all our data into numbers so our model can comprehend it. And lastly, we're going to need data loaders. Models like data loaders because they batch up the data into small little segments, so it doesn't mess up memory, and it makes training a lot better, more efficient. So you got a train and a val. So this is the data loader for the actual train data set, and the val data loader is for the test data set. So I'll go ahead and drag both. Now you're going to see a lot of parameters here, but most of them don't really matter. For num workers, we'll set both of those to 0, pin memory to false. And then our most important is batch size and shuffle. So for batch size, it's essentially how many images are we giving the model at one time. So 32 is always a good number. You know, you're giving it 32 images at a time. It won't stress out your CPU too much. So I'll set 30 to both of those. And then for shuffle, I'll set shuffle to true. Okay, that's literally it for data prep. We have essentially set up our data, and now we can go on to creating our model, which is pretty much my favorite part. So to first create our model, we're going to go up and get an input and an output node. So this is essentially telling MLForge, okay, what is the size of your image and what are the size of the predictions going to be. So these autofill based on the data set before, and a 1,28,28 shape essentially tells us, okay, this is a grayscale image, it's 28 by 28 pixels large. And the output here is how many predictions the model is going to return. So MNIST has 10 digits in total, and essentially the model is setting predictions for all those 10 digits. So let's actually create our model. We're going to create something called a convolutional neural network. And essentially these things are really good at sort of doing computer vision, which is just, you know, exactly what we're doing. So we have this conv2d, which is what we need, and we're going to hook that up to our input. So in channels is going to be whatever number is first. So it's going to be 1 here, and we can set out channels to a multiple of 8. So I'll just do 8 here to keep things small. And then kernel size, stride, and padding. I don't want to get too in depth here, but essentially this is how the layer actually detects patterns. So I'll set kernel size to 3, stride to 1, and padding to 1. And this is going to be my only convolutional layer, and then I'm going to add something called a max pool 2D. This essentially shrinks down the model by half, and you may think it's counterintuitive, but it's actually used for, you know, improving a performance, and it actually doesn't lose, you know, too much accuracy even when you do reduce the size of the image. We'll hook that up. We'll set kernel size to 2, stride to 1, and padding to 1. Essentially, we're shrinking our model 2 times. And then lastly, we're going to do something called a linear layer. This is going to help us produce actual predictions. We need a linear and a flattened layer. So I'll hook up the flatten to max pool 2D, start tim to -1 and dim to 1. Doesn't really matter though. And then after that, we'll hook it up to our linear layer. And this actually automatically calculates. Usually in conventional machine learning, you would have to calculate what it would be throughout the entire thing, but MLForge does that all for you, which is pretty cool. And your out features for your final layer should be whatever the output shape is equal to. So that's 10. And I'll hook it up to the output. And that's pretty much it. That is exactly what you need for a model in MLForge. And we did that in like what, a few minutes maybe, so it's really fast. So let's go over to our right panel here and click refresh on model summary. As you can see, our entire model is 67,352. Our estimated memory is 0.3 megabytes. So pretty small, shouldn't stress out your CPU too much if you're using that. We should be fine. Now it's time for training. So let's go over to our training tab. Let's delete the starter node. And the first thing we'll add is a model and data loader block. So these things reference to previous tabs. Our data loader block references to our train data loader, and the model one, of course, is this entire thing. So the way machine learning actually works here is we get the model's predictions and we get what we actually want for the model. So we compare the outputs versus the labels. And essentially something called a loss function essentially says how bad the model is doing and how we can adjust the parameters of the model to make it better. And the optimizer is something else that's actually going to change the model's parameters to make it better at predicting the data set. So here you can actually see it. Let me move these. So the data loader is going to give the model images, and it's going to spit out some predictions. And then I'm going to get a loss function here, cross entropy loss. Going like this. And then we're going to give the pred right here, which is the model's predictions, and then the labels, which is target. Essentially this cross entropy loss is getting the predictions of the model and the labels and saying, okay, how bad is the model doing? And all these things you can leave blank. They're not necessary at all. And then after that, we can finally add an optimizer. So you can use Atom, AtomW, or SGD. I think I'll just use Atom here. It doesn't really matter. And we'll hook that up. So, and then the only thing we need to specify here is the learning rate. That's how much the optimizer is going to adjust the parameters of the model. So I'll set it here to 0.001, which is a pretty good learning rate for training these models. So that's actually it for training. So in a few minutes, we've created data, our model, and training. And now it's actually time to train and create our model. So let's go up here. As you can see, we don't have CUDA. CUDA is essentially the thing to connect to GPU. So MLForge is telling us, okay, you don't have a GPU, so we're going to train on the CPU. And that should be perfectly fine because our model summary tells us it's only 67,000 parameters, which is pretty small in the scope of machine learning. Most models are like millions of parameters large. So, if you have a GPU or if you don't, you should be perfectly fine. So let's go ahead and hit run and see what happens. So as you can see, we got validated with one warning. We left one of the things blank, which was reduction. We don't need that though. And as you can see, it says 67,000 parameters, our device's CPU, and we're training for 20 epochs. And we specified 20 epochs right here. It's set as default, and you may see val split and just val split over here. And this is really val split and shuffle. These are only really enabled when you only have one data loader. If you have two, these things are completely ignored, so you can ignore that. As you can see in our progress, we see we're on epoch 1, and it's cycling through all the batches and actually training. So I'll let this finish, and we'll see what happens after. Okay, so we've been training for a while, and right now we're on epoch 9. And looking at our graphs, you can see our accuracy is all the way up here, and this is what our train and validation look like. We can turn on our batch as well just to see the loss every single batch. But I think this is enough. We haven't had a best checkpoint in a few epochs, so I'll just go ahead and click stop. So our training is completely done. Not really done, but we stopped it. So let's go ahead and actually run some inference. So first we'll check what it actually looks like. So I'll open up my file explorer, machine learning, and check out what we have in our project. So we have our .mlf and our checkpoint here, which is our best. So if you let training go completely until the end, you'd have a best.pth and a final.pth. So you have two models, and but here we actually ended early, so we're just gonna have one. And so what we're gonna do right now is we're actually gonna run some inference, see how our model actually does. So we're gonna click on run at the top here and then inference. And then it wants a checkpoint, so I'll go ahead and browse. I'll go back and find our checkpoint. So desktop, machine learning, then projects, project 1, our checkpoint, and then our best.pt. Great. And then we'll create a new sample here, so you can see that's a 0, and we'll run some inference. As you can see, beautiful. As you can see, it's 96.4% confident that this is a 0. So you can try it as many times as you want. We'll try a new sample, create another sample, of course. And as you can see, yeah, so it had a 97% accuracy. It's a very good model, and we did that completely without any code whatsoever. But what if you wanted to actually export this to code and actually edit it later? So what we would do here is, let's first save our project, and I'd go to File, Export, Python, and then to PyTorch. So then I want to go ahead and save this in my project file, so I have to go back here, do it all again, machine learning, projects, project 1, and then this would be train.py. So let's hit the OK on that, and that's it. We just exported our PyTorch script. So let's go ahead and go into our file explorer and actually check this out. So our projects, project 1, and our train.py. I don't want to run it. I need to open this with, let's open this with like VS Code and see how it actually looks like. And look at that. You have a completely pure PyTorch file that you can run yourself, and you can also play around with. Let's say, you have transforms over here. I can throw in another transform, like transforms.normalize or something, anything like that. You can edit that. We've exported a pure PyTorch. We created a model, and that's essentially MLForge. You're able to visually create a machine learning pipeline and then actually export that to PyTorch and actually experiment with it, all without writing a single line. So I hope you enjoyed. I hope you use this tool. Remember to like and subscribe. See you in the next one. Goodbye.